Okay, example number 1. Determine the deflection 2 meters from the right support. And assume a constant EI. So first is, before assigning a letter, you have to get first or illustrate the deflection or the elastic curve. Okay, that is just an assumption. So tarong lang na to. Okay. Wait, what happened? Hello. There. And then it says that we are going to get the deflection at 2 meters. So maybe here, this is 2 meters from the right side and 2 meters because we have a 4 meter all-in-all length. And at that portion, we need the deflection. So we need the deflection. And what we're going to do now is copy the beam and redraw the beam here. So I am now redrawing the beam and label now the letters at every change of load, B, A, B, and then point C to be placed where deflection is asked, and point D. This time we are now ready to solve for the reaction, RA and RD. Then let's do the summation of moment. At the point D equal to 0, you will have RA times 6 equal to 40 times 4. So RA is might as well just use this one there. So it's going to be 40 times 4 divided by 6. So it's 26.667. kilonewtons. And then summation of forces vertical equal to 0. You will have RA plus RD equal to 40. And since RA is already 26.667, you just have to subtract that from 40. And the answer is 13.333 kilonewtons. Okay, what we're going to do now is to cut through each segment. So let's start with AB. And we will consider the left section because it's obvious nga sign ra siya nga section sa kanang side compared sa right side. Okay, so this is for segment AB. So draw the beam of the portion of cutting. Okay, something like that lang. And then of course this is your point A, then you have RA, and at the point of cutting you have M. And since na-consider it as a left side, we are gonna bear the counterclockwise direction, and the length of cutting is X. Let's put it in a function of X, and then do the summation of moment at the point of cutting equal to 0. So clockwise positive, counterclockwise negative. You have negative moment M plus RA times X equal to 0. Transposing M to the other side, it will now have RA times X. But RA is 26.667 X. This is your segment. Okay, next segment. Segment BC. So for segment BC, we're going to cut through BC, and then in my case, we're going to consider the left side again. So karon kay I have to redraw the section, and this is quite longer, so place a longer section. Then of course, do not forget to place the letters point A, and then this will be your RA. And then somehow another is a point B, so you have to place the 40 kilonewtons. Do not forget. And since we're through with segment AB, this time the distance between A to B is now 2 meters. And atong i-move ang function sa X towards BC. And at the point of cutting, we have this moment. And since nagyapunta sa left section, so consider the counterclockwise. And this time, the function of X will now be from point B towards the point of cutting. This is now the value of X. So we're now ready to do the summation of moment at the point of cutting equal to 0. You will now have negative M plus RA times the distance is X plus 2, then minus 40 times X equal to 0. Transposing negative M to the other side, it will become positive. Then you copy RA times X plus 2 minus 40X. Substitute RA, which is 26.667 times X plus 2 minus 40X. Do not distribute the 26.667 to X plus 2. Okay, para at least dili siya ma-complicate sa imong solution. Anyway, it won't matter since your calculator is just going to solve it for you. Let us continue with the next segment, segment CD. And it's obvious that I will be considering the right side because it's simpler figure. So this is segment CD. So for segment CD, copy the beam, the previous beam. Or oh, what's happening? Okay, so this is point D at the point of the right side. RD here, and then this is the point of cutting, so we'll have moment M. This time we're considering the right side section of the segment, so it's now clockwise, no? Then this function, instead of 2 meters from C to D, it's going to be X. Now we're ready to do the summation of moment at the point of cutting, clockwise positive, counterclockwise negative. So you have positive M, since it's clockwise, then minus RD X equal to 0. So transposing RD to the other side, it will become RDX. And M here is 13.333X. Okay, the next thing that we are gonna do is draw now the conjugate beam. Virtual beam. So this is for the virtual beam, and let's copy this. Actually, all we have to do is copy the whole beam. So copy the whole beam, but you have to get rid kani wala ni siya labot sa original given there, but you would still be having the same letters A, B, C until D. Then let's remove the reaction here, just to clarify that the reaction that we will be getting here from the virtual beam is no longer the same from the actual beam. And of course, you're going to remove the given load or applied load. At this time, we're asked to solve for the deflection at 2 meters from the right support. So deflection, and we assume that the deflection is going down. So downward ang deflection, no? So mo na atong assumption nga na diri ang ato ang point of deflection. So it's downward. Pasabot, we're gonna place the 1 unit at the point where deflection is asked, and that is 1 unit. And this time, we will now be solving the next values of reaction. So instead of RA, I'll be calling this as AV. And this one, DV, just to denote that these reactions aren't the same from the previous. Anyway, it's obvious man sa, diba, since you have the 1 unit load instead of 40, no? So let's do the summation of moment at the point of D equal to 0 to solve for AV. Times 6 equal to 1 times 2. So AV is 1/3. So ang unit is unit. Then summation of forces vertical equal to 0. You will have AV plus DV equal to 1. Then DV is 1 minus 1/3. So the DV is now 2/3 unit. Okay. This time, we are going to draw now the next segment. So same segment AB. But this time, the segment, you have to follow this. Ang iyahang direction, yung consideration in segment AB is on the left side. So I'll use this. This one. Cutting here and considering the left. Again, be consistent. We're considering the left here, so therefore left pud na diha. Next, you draw the beam. So the section of cutting. So this is for segment AB. Okay. And this is for point A, and you have a vertical. And at the point of cutting, you will have the same direction. So it's counter. And this time, it's no longer capital letter M, but small letter m. Then we will be placing the same X. So do the summation of moment at the point of cutting equal to 0. So you'll have negative small letter m plus a vertical times x equal to 0. So transposing negative m to the other side, it will become positive, and you will have AVX. And AV is 1/3, so it is moment equal to 1/3 of x. So that is the equation. No, do not forget na asad kay equation diha. Next, let us continue. We will be cutting through the next segment, BC, here. And consider the same side, left. So this is the next segment. So segment BC. And for the next segment BC, all you have to do is draw the beam and then place point A with AV, and then point B, and of course this is 2 meters now. And of course wala man ay load diha, diba? So wala na kaibot ang load, do not forget that. And then at the point of cutting, small letter m, then counterclockwise. And then the boundary, the X here. This is now X. Now we're ready to do the summation of moment at the point of cutting equal to 0. So we'll have m, negative m, plus AV times x plus 2 equal to 0. So you will have positive m equal to AV, which is 1/3 times x plus 2. So this is now your equation for segment BC. Now next segment CD. So for segment CD, we will be cutting this CD, and here right side man diha, so of course the same gihapon, be consistent. Okay, the next is we'll have this consideration. And we have that point D, and this is your DV. And then at the point of cutting, you'll have small letter m, then it's now clockwise. So clockwise na siya, no? Of course. This time, it's no longer 2, but it's x. Now, summation of moment at the point of cutting equal to 0. You will have small letter m clockwise minus dv times x equal to 0. So small letter m transposing dv to the other side, it will become dvx. And do not forget, dv is 2/3 of x. This is now your equation. Okay, so the next thing that we're gonna do is get now the deflection. And it is, our assumption is downward, right? No. Okay, mama na siya. And it is equal to the summation of the integral from a to b. So m times m dx. So it is the product of capital letter M and small letter m dx over ei. This is from a to b plus the integral of the same product m dx over ei, and this is from b to c, then plus the integral of the product of moment capital letter M and small letter m dx over ei, and this is from CD. And the limit, so I'll just place the limit here. This is from 0 to 2. Why? Because we're gonna use the limits that will start from 0 and it ends with the length or the distance of the segment. No? So ang distance sa segment sa A to B is 2 meters. And how about for BC? So mag-start siya sa 0, then mo end siya sa 2 meters, but BC is 2 meters. The same with CD. So this is 0 to 2. Okay. So the next thing that we're gonna do is get now the product, starting with AB. So for AB, all you have to do is copy this. So 26.667. So it's 26.667 x times 1/3 of x dx. Asa man nagikan ang 1/3? It's from here. Again, this is the segment for AB for virtual, and this is the segment equation for AB in the real beam over EI. And then ang limit is from 0 to 2. Then plus the integral of, so the integral of unsa man kani siya 26.667. So here this is 26.667 times x plus 2 minus 40x times 4 BC. It's 1/3 of x plus 2. It's 1/3 of x plus 2 dx over ei. The limit is from 0 to 2 again. Next, plus the integral of the next segment. The last segment is CD. You have 13.333. What's happening? So it's 13.333x times 2/3 of x dx over ei from 0 to 2. So you will have here the deflection downward assumption deflection equal to. So let's start with this integral. So let's clear that all. And integral of 26.667 x times 1/3 of x, limits from 0 to 2. And the answer there is 23.704 over ei. Then plus the next integral. So the next integral is 26.667 times x plus 2 minus 40x, and then times 1/3 of x plus 2, and then the limit is from 0 to 2. So it's 77,039 over ei plus the last one. It's pila na siya. It's integral of 13.333 times x times 2/3 of x, limits from 0 to 2. You will have 23.704 over ei. And what we're gonna do now is get everything. So you have 23.704 plus 77.034 plus 23.704 over ei. So the answer is 124.442 kilonewtons cubic meter over ei. So this is our deflection 2 meters from the right support. There. This is our example number 1.